Battlefields and fighting are by nature hazardous to your health. Some hazards are easy to identify and well understood. Soldiers recognize the serious hazards presented by incoming artillery shells and bullets and take appropriate actions. However, some lesser hazards from new technological applications are not so well known and recognized. One of these newer applications is the use of depleted uranium in munitions and equipment armor. There are 4 general situations during which depleted uranium may present hazards to soldiers. 1. If the equipment is damaged or destroyed in combat or in an accident. 2. If the equipment has a serious malfunction. 3. If the equipment is misused and or precautions are not taken. Or 4. If you encounter captured or disabled enemy or even some allied equipment containing radioactive material. We need a basic understanding of depleted uranium hazards. What is depleted uranium? How and where is depleted uranium used? What are the potential hazards of depleted uranium? What are appropriate precautions and preventive measures to follow? Depleted uranium is obtained from uranium ore, which is found throughout the world. In the United States, this ore is mined in New Mexico, Colorado, Wyoming, Utah, and Arizona. Uranium ore contains 3 isotopes. By weight, 99.28%, which is uranium-238, 0.71%, which is uranium-235, and 0.0058%, which is uranium-234. Of these 3 isotopes, uranium-235 and uranium-234 are used for nuclear fuel and weapons. Uranium-238 becomes depleted uranium. To separate uranium-238 from the uranium-235 and uranium-234, the ore is run through an enrichment process. The material left is almost totally uranium-238 and a very tiny amount of uranium-235. It is then called depleted uranium because the natural radioactivity is substantially reduced. Depleted uranium is cheap, plentiful, and easy to machine into various products. Depleted uranium has 2 important physical properties. 1, it is pyrophoric. This means that depleted uranium can ignite upon impact with armor or other hard materials, making it an ideal kinetic energy penetrator. 2, depleted uranium is about 1.6 times as heavy as lead. This high density means depleted uranium is an excellent armor plating because very few materials can penetrate it. Depleted uranium is used as armor in the Abrams M1 series tanks and as 105mm and 120mm kinetic energy penetrators, or M60 and M1 tanks. Depleted uranium is used in 25mm rounds for Bradleys and 20mm and 30mm rounds for aircraft. A kinetic energy penetrator is a non-explosive round made of a high-density material formed into small diameter rods of various lengths. They are used to destroy armor and other hardened targets. Other uses for depleted uranium include ballast in missiles, as counterweights in aircraft, and as radiation shielding. The 2 main depleted uranium health concerns are 1. Heavy metal toxicity. 2. Radioactivity. The first concern, heavy metal toxicity, may occur if depleted uranium enters the body through open wounds, inhalation, or ingestion. During depleted uranium impact or fires, shrapnel and depleted uranium oxide are formed. Depleted uranium shrapnel includes any materials contaminated with depleted uranium. Depleted uranium oxide is a very heavy, dull black dust, ranging in size from cigarette ash to small marbles. Because depleted uranium dust is much heavier than normal dust, it is usually deposited on the surface of the vehicle or within 50 meters downwind of the fire that generated it. Depleted uranium dust or smoke may be inhaled if respiratory protection is not worn. It may also be picked up and ingested if gloves are not worn, and the dust is not washed off before eating, drinking, or using the latrine. Depending on how much depleted uranium is inhaled, swallowed, or gets under the skin, heavy metal poisoning may occur, which can cause damage to internal organs and tissues. A possible long-term hazard from depleted uranium dust is contamination of the ground and water supply. The second concern, radioactivity, results from the spontaneous emission of alpha and beta particles, or gamma rays, from the atom. Radioactivity emitted by depleted uranium can be detected with already fielded radioactive equipment, like the PDR-27 or the ANVDR-2. Health effects of ionizing radiation depend on whether it is alpha, beta, or gamma, and if the radioactive material is inside or outside the body. Alpha is the least penetrating, but is the most hazardous if it does get into the body. In contrast, beta and gamma are more penetrating, but do not cause as much damage within the body. Depleted uranium emits primarily alpha particles, which means that there is no immediate external hazard because alpha particles do not penetrate heavy clothing. Identifying vehicles hit by depleted uranium kinetic energy penetrators is simple. The entry hole will be small and round. In some cases, you may see thin lines surrounding the hole if the metal was soft or thin, such as the aluminum sheet around the outside of the Abrams turret ammo compartment. While all kinetic energy penetrators leave small round holes, only a depleted uranium impact will leave a detectable radioactive signature. In most cases, there will also be spalling around the edges of the hole. The spalling looks like melted and rehardened solder. There will also be radioactive depleted uranium dust on the vehicle surfaces. The depleted uranium penetrator usually goes through the vehicle without breaking up. This results in a small, round radioactive exit hole, only slightly larger in diameter than the entry hole. You may see spalling around the hole or within the vehicle, and burning will usually have occurred. In contrast, conventional high-explosive munitions leave large entrance and larger blown-out exit holes with no radioactive signature. Two other types of radioactive hazards you may encounter on the battlefield are 1. Tritium, and 2. Radium. Tritium and radium are used in self-luminous diodes and gauges. Radium in old ones, tritium in new ones. Tritium is not a hazard as long as the diodes and gauges remain sealed. If a tritium device is broken on the battlefield, stay away from it and immediately notify your unit chemical officer or NCO. Tritium emits beta particles, but the energy is so low that normal radiac meters cannot detect them. Nevertheless, it is there. Stay away from it. The second type, radium, is a gamma emitter and can be detected with radiac meters. Do not pick up, handle, or take foreign items with diodes or devices that glow in the dark. They probably contain radium. Avoid all cracked or damaged diodes and gauges. If you suspect contamination, you should use hazard avoidance techniques to protect yourself and your equipment. The three principles of radioactive hazard avoidance are: 1. Time. Minimize your exposure time to the radioactivity. For example, set an operational exposure limit. Rotate your crews to reduce total dose. Or rehearse your mission to improve performance and eliminate unnecessary tasks. 2. Distance. Maximize the distance between yourself and the radioactive source as much as possible. 3. Shielding. Shielding is placing a barrier between you and the radioactive source. Use anything available. In this case, even cardboard, tape, and paint are effective. Your objective is to complete the mission safely and avoid the spread of contamination, specifically the depleted uranium dust. Remember, always keep away from contaminated equipment or terrain if possible. But if you must work with contaminated equipment, follow these specific steps to keep hazards as low as possible. 1. Contact your unit chemical officer and medical officer. 2. Cover up exposed skin by rolling down your sleeves and blousing your pants, or by putting on your mop suit. This reduces exposure because alpha particles cannot pass through the material. 3. Don respiratory protection. If you plan on being in the vehicle or working on the equipment for only a few minutes, a handkerchief or dust mask worn over the mouth and nose will provide adequate respiratory protection. For longer exposures, put on your protective mask. 4. Perform a visual inspection to identify explosive hazards. Destroyed or contaminated vehicles which may contain unexploded or unstable munitions should be marked, secured, reported, and left for specially trained recovery retrograde teams. Caution: if you are in an Abrams, Bradley, or other vehicle that is hit with depleted uranium munitions, you may have unexploded or unstable munitions. These munitions may or may not retain their normal shape. Because depleted uranium contamination is not a hazard requiring immediate decontamination, your commander will decide when to complete operational decontamination if you find radioactive depleted uranium contamination on yourself or a vehicle. To perform operational decontamination, select a site away from water sources, food storage or eating areas, and occupied bivouac sites. Then, brush, scrape, or wash off loose radioactive dust from yourself and or the vehicle. Mark the area so others know it is contaminated. Depleted uranium that is fixed or embedded on the vehicle may be covered with duct tape, cardboard, or whatever you have available. The location and type of depleted uranium contamination must be reported up command channels through the Nuclear, Biological, and Chemical Warning and Reporting System. Report the dose and location with an NBC-4 report. Remember, depleted uranium is not an immediate health concern. Treat injuries in accordance with the Soldier's Manual of Common Tasks, STP 21-1 SMCT. If you or your soldiers are injured in a depleted uranium-contaminated situation, follow these steps. 1. Use a radiac meter to check each wound for radiological contamination. 2. Wash out all minor cuts on hands, arms, or legs to remove any radioactive or heavy metal contamination. 3. Contact the medics. For all major wounds, leave embedded particles in place and tell the medic that radioactive and heavy metal materials are involved so that appropriate medical care can be provided. 4. Mark the field medical card, DD Form 1380, to indicate radioactive and heavy metal contamination. Awareness of depleted uranium hazards and common sense procedures will effectively protect you until the contamination can be removed or your equipment can be replaced. Remember, depleted uranium is not an immediate hazard. The two health concerns about depleted uranium are heavy metal toxicity and radioactivity. If you are involved in a depleted uranium situation, 1. Minimize your exposure time. 2. Maximize your distance from the depleted uranium. And 3. Use protective clothing and any shielding available. Bottom line, unless you're involved in a detonation or fire with depleted uranium, hazards are relatively small.